Afternoon, grade 11s. Welcome to your second distance learning lesson. Today we're going to be expanding on what we did yesterday, where we first got introduced to the mole, and today we're going to do a little bit more calculations with the mole and do some more practice problems. As a reminder, we have this video tutorial to help you go through the slides to make sure that you're understanding everything that we're going through. Also, feel free to reach out to me by email or Google Classroom. Remember that the office hours that have been posted for you are the easiest way to get a hold of me really quickly. Otherwise, just be patient. I will be checking my email often, and I'll get back to you as soon as I can. Okay. So today we are still in the same textbook sections as we were yesterday. We're just looking at some new practice problems that we didn't get to. So we are going to be in 6.3 to 6.5 of your book, page 266 to 283. So we're going to start off with a little bit of review. We're going to do some extra practice problems similar to the ones that we saw yesterday to make sure that we're all on the same page from yesterday's lesson. Then we're going to learn some new types of calculations. We're going to be looking at mass, moles, and entity conversion. And then we have a couple review activities for you to do at the end to make sure that we're all on the same page. Okay. Again, today's module shouldn't take you more than about an hour. And it will be building on as well from what we did yesterday. So by the end of class today, what you should be able to do is easily convert between number of entities, number of moles, and mass. Okay, so last day we did go through some new formulas or new short forms that we are going to be continuing to use throughout the rest of the year, the rest of the course. So I just wanted to make sure that we were all clear about what each of these variables are representing in our different calculations. So Avogadro's number, remember a big N is where we're always going to be counting some sort of number of some sort of entity, okay? So when it's N sub A, that's a specific number, specifically Avogadro's number. We know Avogadro's number is 6.02 times 10 to the 23, and it represents the mole. And the mole just being a fancy word that represents a very big number in this case, similar to how the word a dozen represents the number 12, okay? A lowercase n is always going to represent your number of moles. Molar mass is always going to be a little m with a big M. Mass, which is a new one that we're going to be looking at today, is represented with a capital N, and number of particles, whether that be formula units or molecules or ions or atoms, is going to be represented with a big N. Okay, so yesterday we did practice formulas using capital N, lowercase n, and n sub a. Today we're going to be learning some new formulas that also incorporate molar mass and mass to do some more conversions. Okay, so yesterday we did take a look at how we convert between number of moles and number of entities. So we went through this formula. Number of particles is always moles times Avogadro's number. Okay, so Avogadro's number is really how we connect moles to number of entities and how we do that conversion. So again, big N being number of entities, whether it be ions, atoms, molecules, formula units, whatever you're counting up, is always going to be the number of moles times Avogadro's number. So the formula in and of itself isn't really that difficult to use. It's just right now you're probably getting comfortable remembering the difference between the different variables. So what's a big N versus a little n, because those are really important. And like I said, this isn't going to disappear for the rest of the course. If you were having problems calculating the questions yesterday, you may want to answer questions using this guess format. Now, this isn't required for you to on test quizzes or exams. Again, I'm just going to be marking the way we went through yesterday, a mark for your formula, a mark for showing your work with units, or your mark for your final answer with units. But if you're having trouble staying organized, and for today's lesson, I'm going to be using this format just to help those out that may be having a little bit of a hard time. It says the saying usually is, if you don't know the answer, just take a guess. So guess being G, starting off by writing out what are your givens. That may give you a hint as to what formula you could use. Then your U is what is your unknown. What are you trying to calculate for in this question? E is then picking your appropriate equation. Okay, making sure that you include that because that is for marks, just like we've done all year. S is put in your solution. So plug in all of your knowns to figure out your unknown and get your final answer, and then end with some sort of statement. Okay, that may help you stay organized, and as we learn more and more formulas and you're trying to pick between which one is appropriate, using this setup may help you know which formula to pick more easily. Okay, So we're going to go through a practice problem. I'm going to make myself disappear here so we can do some calculations together. So this one says how many molecules are in 3.67 moles of carbon dioxide. So again, carbon dioxide we know is CO2, and the reason that we're using molecules here is because this is a covalent compound, okay? Or it's two nonmetals. So that's how we knew to say how many molecules versus formula units, atoms, ions, what have you, okay? If you're still having trouble with that, take a look back at yesterday's lesson, lesson 1, and we did go through examples of when we would use each of those terms, okay? So we did learn our formula. Number of particles, okay, is always our number of moles times Avogadro's number, okay? So we're going to be using this formula and continuing to use this formula today. Okay, and I'll write it up here. Number of particles is moles times Avogadro's number. So if we are having trouble and you're using that guess format, first we're going to say, well, what were the givens in the equation? Well, one thing I was given in the question is it did tell me that it was 3.67 moles. So one thing that was given to me, lowercase n, that represents moles, I know that I have 3.67 moles. The other thing that is essentially always given to us because it is a constant, this number never changes, is we do know Avogadro's number is going to be 6.02 times 10 to the 23rd. And because we're calculating this for carbon dioxide, this is going to be molecules a mole, again, because carbon dioxide is a covalent compound. It's made of two nonmetals. Okay. Next is U. What's my unknown? Well, it's asking me how many molecules are there. So what I am calculating is my number of molecules of carbon dioxide. That's what's unknown. So when given number of moles and Avogadro's number, we're trying to figure out number of particles. Oops, let's go back here. So the equation that I'm going to use is the number of particles is moles times Avogadro's number, okay? Like I said last day, if you are having trouble as well, we can use this formula triangle. I would encourage you though to try to practice moving the variables along as you go, but if you are struggling with it, that is an option for you. Okay, so we're going to put in our solution. We're going to plug in our numbers. So number of moles, little case n, was given to us. It's 3.67 moles. And we need to multiply that by Avogadro's number, which we know always stays the same, is 6.02 times 10 to the 23, and in this case, molecules a mole. Okay. So if I put that in my calculator, what I'm going to type in is 3.67 times, remember I'm going to put 6.02 and press that immediately, that EXP or EE button on your calculator, to the 23rd. And that's going to give me 2.21 times 10 to the 24. And because I'm calculating n here, I'm calculating how many molecules I have. So my final S, my statement is, I would say there are 2.21 times 10 to the 24 molecules of CO2 in 3.67 moles. Okay. So this guess format may help you get through this a little bit easier, but reminder, what you're actually going to get marks for is a mark for showing your work with, a mark for your formula, a mark for showing your work with units, and a mark for your final answer. So this would be out of 3. Okay. So that should be review from yesterday. Let's do one more. It says if I have 2.57 times 10 to the 11 atoms of silver, how many moles of silver do I have? So I'm going to set it up with guess. What was given to me? Well, it says I have 2.57 times 10 to the 11 atoms. So that's my big N. That's my number of silver atoms. Okay. So I'm going to put that in as 2.57 times 10 to the 11 atoms. And it's atoms because it's neutral silver at this point. Silver is just one thing off the periodic table and it doesn't have charge, so it's not an ion. And like always, even though it's not explicitly given to us in the question, we always know Avogadro's number stays the same at 6.02 times 10 to the 23. And this time I'm going to do atoms a mole because I'm counting up atoms specifically, something neutral off the periodic table. My unknown, because it says how many moles do you have? My unknown here is my moles of silver. My lowercase n is what I don't know. Okay. So the equation I'm going to use is N, big N, is moles times Avogadro's number. In this case, though, I'm not calculating for big N. I need to calculate for little n. So to get little n by itself, I'm going to divide both sides by Avogadro's number, which is going to give me the formula moles is number of particles divided by Avogadro's number. You also could, if you were using your formula triangle, okay, if I cover up moles, I'm left with number of particles over Avogadro's number, which is the same formula I have right here. Okay. So now I'm going to plug in those values. So I have 2.57 times 10 to the 11 atoms. And I'm going to divide that by Avogadro's number, 6.02 times 10 to the 23rd atoms a mole. So here's a good example where, because I have two things in scientific notation, it's going to be easier if I'm using that EXP or EE button. So what I'm going to type in my calculator is 2.57. Immediately I'm going to press that EXP or EE button, which is going to tell my calculator times 10 to the, and then I'm going to put in 11. So I just typed 2.57 EXP 11. Okay. Then I'm going to divide that by 6.02, press that EXP button, 23. That's going to give me 4.27 times 10 to the negative 13 moles. Okay, so that's my S. Okay. So my final thing, what I need to put in as my statement is there are 4.27 times 10 to the negative 13 moles in 2.57 times 10 to the 11 atoms of silver. Okay. How we would get marked on a test or quiz or exam, you would get a mark for your formula, you would get a mark for showing your work with units, and you would get a mark for your final answer with units. Okay. So the new stuff that we're going to learn today, those first two practice questions were just a review from yesterday to make sure that we're all on the same page from what we were doing. We're going to look at how we can convert between mass and moles. Okay, so this is a new concept that we didn't do yesterday, so we're going to be learning this new formula. Okay, so molar mass, which we did learn how to calculate molar mass yesterday, is the connection between the measurements of mole and mass. Okay, so this should say, mole and mass. So if we know how much a mole weighs, because we know molar mass, we can figure out how many moles we have if we know how much mass we have, or how much mass we have if we have a number of moles. So the new formula that we're going to learn today is moles is mass divided by molar mass. Okay? So we're going to learn how to practice that. So this says calculate the number of moles present in 257.354 grams of potassium chromate, or K2CrO4. Okay? So first we have to do is figure out what we were given. Okay? We don't need Avogadro's number this time because we're not actually using number of entities. Okay? What was given to us instead of big N here was big M. We were given mass, which is 257.354 grams. We also can, based on the formula given to us, figure out the molar mass of K2CrO4. Okay? So we can figure that out. It wasn't explicitly given to us, but we can figure it out, okay? So how I'm going to do that, I'm just going to take a look on the side here. Remember, molar mass, we just have to add up the individual molar masses of each of those elements. So, molar mass of K2CrO4 is going to be the molar mass of potassium, but we need to multiply that by 2 because it's K2. We're going to add to that the molar mass of chromium. We're only going to have 1 because there's only 1 of that. And we need to add to that 4 times the molar mass of oxygen because we have 4 oxygens. Okay, so we need to look up those numbers on our periodic table. Okay, potassium has a molar mass of 39.10 grams per mole, and I'm going to multiply that by 2. Chromium has a molar mass of 51.99 grams per mole, and we don't need to do anything to that number because we only have 1. And then the molar mass of oxygen is 16 grams per mole, but we have 4 of those. Okay, so if I put that in my calculator, putting that in now. Okay, we're going to get, oops, made a mistake there, sorry. So we need 39.1 times 2. We're going to add to that 51.99, and then add to that 16 times 4. Okay, we're going to get 194.19 grams per mole for K2CrO4. We'll put that, that's 1, it's not explicitly given to us, but we are given enough information that we can calculate it. Okay, what's unknown in this case is it's asking us for the number of moles, so our lowercase n is what's unknown to us right now. Okay. So we're going to be using this new equation that we just learned, which is moles is mass divided by molar mass. Okay. Again, if math is tricky for you, you can use a formula triangle. I would encourage you to just practice using shifting of variables, but you can use this if you would like. And this formula triangle would look like that. Okay. So now that we know our equation, we're going to plug in our values. Our mass was given to us 257.35 grams. Our molar mass we calculated because we were given the formula, 194.19 grams per mole. Okay. So plug that in. You should get 1.33 moles. Okay. So what I would say, my final statement is there are 1.33 moles in 257.35. Oh, I forgot to put the 4 in, but we should be close. Grams of K2CrO4. So my marks here, if this was a question on a test or a quiz and every exam, this one would likely be out of 4. Okay, you would get a mark for your formula. You would also get a mark for calculating your molar mass properly. Okay, which is new, that we didn't see in the other questions, but because there's this extra calculations, okay, you would get extra marks for them. Then, like we did before, you would get a 3rd mark for showing your work including units, and a 4th mark here for your final answer including units. So because you had to actually calculate your molar mass, you would get an extra sort of credited mark for that. Okay. Okay, let's do one more. How much does 0.33 moles of sodium chloride weigh? So we're going to start off saying, okay, what was given to us? Well, the first thing, we know our number of moles. It was given to us right here. So our lowercase n, we know we have 0.33 moles. Now, also similar to the last question, we can figure out the molar mass of NaCl really easily because we are given the formula. Okay. So in this case, we would say, well, the molar mass of sodium chloride is just going to be the molar mass of sodium plus the molar mass of chlorine. Okay, So if we look that up on the periodic table, sodium is 22.99 grams per mole, and chlorine is 35.45 grams per mole. So if you add those two numbers together, you would get 58.44 grams per mole for sodium chloride. Okay. The unknown here is it's asking us how much it weighs, and weight is measured in mass. So we don't know how many grams we have. Okay. So the equation we're going to use, same one we learned last day, we said moles is mass divided by molar mass. Now, we don't need to calculate moles this time, we want to calculate mass. So to get mass by itself, we need to get rid of molar mass. We need to multiply both sides by molar mass. So what we would be left with is mass is molar mass times moles. Same thing if we use that formula triangle. Okay, if we're trying to calculate mass and we cover up mass, moles and molar mass are now beside each other, so we know to multiply those two terms together. So molar mass we calculated 58.44 grams per mole, and we need to multiply that by 0.33 moles. This is our solution. So what we're going to get is 19.29 grams, because mass is going to be measured in grams. So what I would say is 0.33 moles of sodium chloride weighs 19.29 grams. Okay. Again, this would be out of 4 if it was on a test or quiz or exam. You would get a mark for your formula, a mark for calculating your molar mass correctly, a mark for showing your work including units, and a mark for your final answer including units. Okay, pulling it all together, we're going to do one question now that connects both of those two formulas we took a look at yesterday and today. So remember, the two formulas we've learned is number of particles is moles times Avogadro's number, and we also learned that moles is mass times molar mass. Okay, so in this case we're going to have to use 2 because it's asking us how many particles would be in a mass of sodium chloride. Okay, so let's take a look at this. So what's given to us in the equation? Well, a few things are given to us. First, we know the mass of sodium chloride. Here is 500 grams. It's given to us in the question. We can also know the molar mass of sodium chloride. We did calculate it on the previous slide. It was 58.44 grams per mole. Still going to be the same. I'm just going to put that in, 58.44 grams per mole. And we still do know Avogadro's number. We always know that to be true. It's always 6.02 times 10 to the 23rd. Okay. In this case, because it's sodium chloride, this is an ionic compound, okay, because it's a metal and a non-metal. So this would be 6.02 times 10 to the 23 formula units a mole. Okay. So we're going to actually need to use 2 equations this time. First, we're going to have to convert mass into moles. Then we can convert moles into number of particles. So we're going to be using both of our formulas, okay, of number of particles is mass times molar mass. Or first we're going to use moles is mass divided by molar mass. And we're also going to be using number of particles is moles times Avogadro's number. So let's start here with our first equation. We know we're given to our question that 500 grams is our mass, and we calculated on the previous question that a molar mass of sodium chloride is 58.44 grams per mole. That means we can calculate really easy how many moles we have, which is 8.56. We'll leave a couple more extra decimal places this time just because it's a midpoint calculation. So we'll go 8.5558 moles. Now that we know number of moles, we can figure out number of particles, okay? Because we just figured out from this question how many moles we have. So 8.5558 moles. And we always know Avogadro's number. So if we now multiply that number by Avogadro's number, we're going to get 5.15 times 10 to the 24, and this is going to be formula units. So there's my solutions. So my statement would be there are 5.15 times 10 to the 24 formula units in 500 grams of sodium chloride. Now, if this was a question on a test or a quiz or exam, this would likely be out of 7. Tell you why. You would get a mark for using this first formula correctly and calculating your molar mass correctly, as well as showing your work with units and your first final answer with units. Then you would also get a mark for your secondary formula, showing your work and your final answer in that formula, and your final answer with units. Okay, so overall it would be out of 7 because you're using 2 formulas and calculating molar mass. Okay, one last question we could take a look at is it says how much does 1.45 times 10 to the 25 molecules of water weigh? Okay, so now we're going from number of particles to mass. So the only way we can get between number of particles and mass is always through the conversion of moles, okay? Because moles is in the number of particles formula and moles is in the mass formula, okay? So let's start out getting ourselves organized. What is given to us, okay? First, we know how many molecules, and this is molecules because it's covalent. Okay, water is made of 2 nonmetals. We do know we have 1.45 times 10 to the 25 molecules. We also know Avogadro's number. It's always true, 6.02 times 10 to the 23. This is going to be molecules a mole. We also can figure out the molar mass of water just by calculating it. Okay, so take a look down here. Molar mass of water is going to be the molar mass of hydrogen times 2 plus the molar mass of oxygen. So that's going to be 2 times 1.01 grams per mole plus 16 grams per mole is going to give us 18.02 grams per mole. Okay. Unknown, we're trying to figure out mass. We don't know how much mass we have because it's asking us how much it weighs. So the equations we're going to use here, we first are going to convert number of particles to moles so that we can then convert moles to mass. So we're going to use both our number of particles is moles times Avogadro's number, and we're also going to use moles is mass divided by molar mass. So this first equation, we want to figure out moles though, because we're given number of particles and Avogadro's number. So to get number of moles by itself, we need to divide both sides by Avogadro's number, which is going to give us moles is number of particles divided by Avogadro's number. If you're using your formula triangles as well, we know number of particles is moles times Avogadro's number. So if I cover up moles, we're left with number of particles divided by Avogadro's number, which is the same formula as right here. So if we plug that in, number of particles is given to us 1.45 times 10 to the 25 molecules and we're going to divide that by Avogadro's number. Okay, so that's going to give me, I'm going to type in 1.45 exp25 divided by 6.02 exp23 should give me 24.0864 moles. I'm going to keep a few more extra decimal places just to not lose some of that accuracy while I'm doing my calculations. Now that I know number of moles, I want to figure out mass. So I also need to rearrange this equation, okay, because we want to get mass by itself. So to get rid of molar mass, we're going to multiply both sides by molar mass to get rid of this, which is going to leave us with mass being moles times molar mass. If you're depending on those formula triangles as well, okay, remember if we're trying to calculate mass and we cover that up, we're left with moles divided right beside molar mass. So we need to multiply those two terms, which is what we're doing right here. Okay, plug in our numbers. We just calculated this, 24.0864 moles. And we know our molar mass is 18.02 grams per mole. So that's going to give us 434.04 grams. Okay, so there's my solution. So I would say 1.45 times 10 to the 25 molecules of H2O weighs 434.04 grams. Now again, this would likely be out of 7. You would get a mark for your formula, showing your work, calculating your molar mass, calculating moles, your secondary formula, showing your work a second time with units, and your final answer with units again. So this type of question would likely be out of 7 marks. Okay, last question we're going to take a look at today is if 1 mole of oxygen weighs 16 grams, how much does 1 atom weigh? Now, you could convert 1 atom, you could treat 1 atom like your big N, okay? Calculate number of moles from that, and then calculate your mass. There is also one last sort of shortcut formula I'm going to teach you, is that the mass of 1 atom is your molar mass divided by Avogadro's number, okay? It's a way or a shortcut of combining our two formulas together, okay, by getting rid of moles. This is just sort of a shortcut. So if I'm going to do it this way, I would say, well, what's given to me is the molar mass of oxygen, which is 16 grams per mole, and Avogadro's number, 6.02 times 10 to the 23. And because we're just dealing with oxygen, neutral oxygen, it's going to be atoms. Okay. So the equation I'm going to use is that the mass of 1 atom is molar mass divided by Avogadro's number. And we'll plug that in. 16 grams per mole divided by 6.02 times 10 to the 23 atoms, a mole. And that makes sense. We're saying 1 mole, which is made of this many atoms, weighs this much. If I want to know how much 1 weighs, I'm going to divide that by how many are in a mole. So we should get a really small number, which in this case is 2.66 grams. No, not 2.66 grams, 2.66 times 10 to the negative 23rd grams. So I could say, my final solution, 1 atom of oxygen weighs 2.66 times 10 to the negative 23rd grams. This question, because we're only using one formula, would likely be at a 3. 1 mark for your formula, 1 mark for showing your work with units, and 1 mark for your final answer with units. Now, to review the work that we did today, what I'm going to have you do, on a piece of paper, on half a piece of paper, I want you to show how you can convert between number of entities, moles, and mass. So for example, if I know number of entities and I want to figure out moles, what formula would I use? And you would say, okay, well, I know moles is number of particles divided by Avogadro's number. Or if I wanted to figure out how many, what the mass was for moles, what formula would I use? Okay, so in this case, we would say, well, mass is moles times molar mass. Okay, I want you to also figure out how would you go from there to there, and how would you go from there to there. So 2 are already actually done for you. Then using this formula, this may help you if you have a question like it says, calculate how many particles are in 100 grams of HCN. Well, you could say, well, I started with mass. So I started here, and what formulas do I have to use to get to here? Okay, it may help you sort of keep track, okay, or sort out what formulas to use when if you're still having a hard time with that. Okay, so use this. If you keep this handy and you keep it on your desk while you're doing your work, it may help you organize your formulas and know how to practice the problems. Okay, when you're done that, there's a couple questions from your textbook. Please note when it asks you for the amount of a substance, you should either be calculating mass or number of particles, depending on how the question is asked. Okay. Again, we're going to do some more practice problems for our third and final module for this week. We'll be working on what's called the mole module tomorrow. You'll submitting that work on Google Forms for me. And again, if you have any questions, reach out via email or on Google Classroom so that we can help you out. Good luck with those problems and stay healthy, stay safe, and stay home. See you soon.